Good morning to everyone. My name is Kalyani Rambhad. I am the student of B.Tech third year in Civil Engineering branch from Tulsiramji Gaikwad Patil, College of Engineering and Technology, Nagpur. I am taking numerical on the topic of shear factor for design of steel structure. So, moving to the numerical. Question is, calculate the shear factor for the given circular shape having a diameter 105 mm. Next, next move to the solution. Then we have given that the diameter for the circular section is 105 mm. Then to find is shear factor. The formula for the shear factor is plastic modulus, that is Zp, upon elastic modulus, that is Ze. Then next, formula for the Zp is equals to a by 2 in bracket y1 bar plus y2 bar. Then Ze is equals to I by y, that is moment of inertia upon y. Then calculation, first of all, calculation of area. Then the area of circular section is pi d square upon 4. Then after putting the value of diameter in the formula of the area, we get the value of area is 8659.01 amps. Next, we take the value of Zp. Then Zp is equals to a by 2 in bracket y1 bar plus y2 bar. Then put the value of respective values. Then Zp is equals to a is equals to 8659.01 upon 2. In bracket, value for the y1 bar y2 bar is 4r upon 3 pi. Then, after calculating values for the Zp, that is plastic modulus, we get the value of plastic modulus is 192,937.39 mm3. Remember guys that the most important thing is the unit for plastic modulus is mm3 and the unit for elastic modulus also mm3. Then numerator and denominator mm3 will be cancelled and shear factor becomes dimensionless. Hence, shear factor do not have any unit. Then next, to find the value of elastic modulus, having a formula I upon y. Then formula for the I is pi d to the power 4 upon 64 and formula for the y is d by 2, that is diameter upon 2. Then applying formula a upon b upon c upon d is becomes a into d upon b into c. Then we can see that the simplification of their formula is pi d to the power 4 into 2 upon 64 into d. Then d to the power 4 d will be cancelled and 64 upon 2 will be cancelled and remaining values are z is equals to pi d cube upon 32. Put the value of d in the formula. Then pi into 105 d cube upon 34. Then after putting the value, we get the value of Ze, that is 113,649.5 mm3. Then now the final step is finding the shear factor. The shear factor is Zp upon Ze. Put the value of Zp and Ze 192,937.39 upon 113,649.5 is equals to 1.69. 1.69 will be approx to the 1.7. Hence, the shear factor for the circular section is always 1.7. Hence, the shear factor for the circular section is 1.7. Thank you.